Okay, so this is a problem I know about sampling distributions. I know it's a sampling distribution means because we're given a mean and a standard deviation. So let's see, what does he say? He says he claims that his cows' weights are fully mature and normally distribute the mean of 1,400 and the standard deviation of 250 pounds. And this person comes out and buys 50 of my cows, and the mean weight of those cows are only 1,300. So how likely is it that you're going to get a sample of 50 cows with a mean weight of 1,300 pounds or less? So what we're doing is, if the true mean is 1,400, 1,400, and we are trying to estimate the probability of getting a sample of 50 cows, so that area is what we're looking for, where the average weight of those 50 cows is 1,300 or less. Okay, so what we're going to do is calculate. To do this the long way with a formula, we're going to calculate a z-score, and I know I can use a z-score because I have a sample bigger than 50, and I know a population standard deviation. So I don't know if you're using t-scores. So I'm going to calculate the z-score for this. So 1,300 is the number we're looking for. The mean is 1,400. And because this is the sampling distribution, we can't just divide by 250, because we know that when we start doing sampling distributions, the standard deviations aren't as large as they are for the population. This is supposed to be 250. There we go. And I'm going to divide that by the square root of the sample size, which is 50 in this case. So that's going to give me negative 100 over, now, so what I'm going to do is I'm going to grab my calculator, and I'm going to take 250 and divide it by the square root of 50. So 250 divided by the square root of 50, that's giving me 35.355, I guess. 35.55. 355. So then I'm going to divide 100 by that number. So that's giving me a z-score of negative 2.82. Okay, so that's a pretty small z-score. And if I get the probability, because that's what they're looking for, you can either use a normal probability table, or you can use an online applet like this David Lane normal applet. And since I've already converted this to a z-score, I know the mean's going to be 0, the standard deviation is going to be 1. Now I want to know, what's the probability of getting a z-score in this case less than negative 0.282. And I'm seeing it's a very small probability, less than less than 0.03%. 0.03%. So it's a very small probability of that's happening if the true average of those cows are 1,400 pounds. So to answer Dr. Stevens' question here, does it prove he's a liar? Well, it's not very likely to get a sample of 50 cows with that small an average, that 1,300 average. So yeah, it's not likely. Probably that 1,400 pound average weight isn't the truth. Okay, now I wanted to show you this one. Now that's using z-scores, and you mentioned about using the formulas. That's the formula. But with applets, you can also do this right here. I'm going to type in 1,400. What if I don't calculate the z-score? Now I know the standard deviation for the sampling distribution is the 35.55 or 355. And I want to go below 1,300 pounds now. And if you see how I'm getting the exact same number, so you don't have to calculate a z-score for this. You can just go directly to a value, as if you can use an applet. Your calculator will do this if you have a graphing calculator. I like this David Lane applet because it kind of gives us the immediate answer. So that's a sampling distribution for means. So for this next problem I'm choosing to do is, let's see. So I know a recent poll suggests that 48% of Americans are satisfied with their job. I have a company of 220 employees, and a poll suggests that 85 of them are satisfied. Is this an unusual amount? Well, to do this as the central limit theorem question, we're going to, they use that whole approximation, the normal distribution, binomial distribution, the normal approximation of the binomial distribution. So is this a binomial distribution? That might be often asked. Well, I know the probability that any one American is satisfied with the job is 0.48. So I guess that stays the same from employee to employee. I also know that I have a fixed number of trials. So I have 220 employees. It's a yes or no kind of question. Are you satisfied with the job or are you not? And let's see, and then it stays the same from employee to employee. So I think the criteria for the other criteria is 0.48 times 200 greater than or equal to 10. Well, it sure is. And if you do 1 minus 0.48, you get 0.52. And 0.52 times 200 is also greater than or equal to 10. So we're okay to do this binomial distribution, or this normal approximation for the binomial distribution. And maybe that's more information than what your professor is looking for, but it is something we should check. So then what we're going to do is we could calculate a z-score. If you're going to calculate a z-score for this, in fact, it may not be a bad idea to do that. I know that the population proportion is 0.48. And I know p hat for the sample proportion is going to be 85 over 220. I just realized I did 2.48 times 200, not 0.48 times 220. Fortunately, that doesn't change the answer. It's even more so. So I'm going to divide 85 by 220. That's giving me 0.38. Or did they tell us that? No, they didn't. So that's about 0.386. Okay, so what we need to be able to do to calculate this is that to have a standard deviation for this, and the way you calculate the standard deviation for sampling distribution for proportions is you're going to do the population proportion times 1 minus the population proportion over n and take the square root of the mess. So in this case, it's 0.48 times 1 minus 0.48 is 0.52 all over 200. And then we'll take the square root. So I'm going to do that on my calculator. 0.48, let's see, 0.48 times 0.52 divided by 200. Then I'll take the square root. I'm getting 0.0. Let's see, where's my board? I'm getting 0.0353. And then I can use this David Lane applet. I may could calculate a z-score. We're all set to calculate a z-score. And if you need some help doing that, let us know. But I'm going to try to use this normal David Lane applet. And I know the mean for this distribution is 0.48. I just calculated that the standard deviation is 0.0353. And I want to know unusually low. So I'm going to go below, let's see, my sample proportion of 0.386. So looking at that probability is much less than 5%, 0.05. So yes, this is an unusual event. This is an unusually low number of satisfied employees if the poll is correct. All right. So I hope this helps you make some headway with this. If you have other questions about this, either join us in eChat or post some more e-questions.